Hey Matrix, welcome to the next video in the Maths Paper 2 playlist. Today we're covering question 8 of the November 2020 past paper. If you don't have the paper, there's a link in the description below where you can go and download the paper as well as the memo. Once you have the paper, then we can continue with the question. Let's get started with question 8. Okay, so question 8 is looking at circular geometry. They've given us the following picture below here. Okay. I've indicated that M2 is 90 degrees, okay, we shall see why later on. Then they've given us that K1 is 32 degrees, one of N's angles here is 26 degrees, and we can see by the first question that we need to find O2 and O1. Okay, so let's get started with 1.1.1a. Okay, so it asks to find O2. Okay. So I've simplified the drawing here. I've taken out some of the lines just to make it a little bit easier to understand. Okay, so this picture over here, we can't use the bow tie theorem. Okay, why? Because we're only in half of the circle. Okay, so what we need to look at is one of our other theorems. We have an angle next to the circumference, and we've got an angle that we need at the center. So the theorem that we need here is normally given as something like this, which states angles at center equals 2 times angle at circumference. Okay, so I'm going to be using that theorem over here. So therefore O2 is going to equal to 2 times K, which is going to equal to 2 times 32, which equals 64 degrees. Okay, and the reasoning there is angle at center equals 2 times angle at circumference. Okay, now for 8.1.1b, they're asking us to find O1. Okay, there are multiple ways about finding O1. I'm going to show you the way that I found was the simplest way and the easiest way to do it. Okay, so as I said early on, M2 is 90 degrees. Okay, how did I get that? Well, we can see that KOM is the center line and LN is a chord in the circle. So from your theorem that states that the center line bisects the chord running across, and they've indicated that NM is equal to ML, okay, which means that KOM must bisect LN. Okay, so I'm just going to state that M1 equals M2, which equals 90 degrees. Okay, the reasoning behind that is line from center to mid of chord. Okay, so we're looking for O1 over here. So now that I have this as 90, I have that angle there as well. So we can consider the triangle NOM. Okay, so I'm going to say triangle NOM. Okay, so this is O3. M is going to then equal to O3 plus M plus N. Okay, there we go. Okay, well, not O3. Oh, I made a mistake there. That should be 180, and these should all be minus signs. There we go. Okay, so now we can plug everything in. So that's 180 minus 90 minus 26. Okay, which should give you an angle of 64 degrees. Okay, now from here I have O3, which is 64 degrees. Okay, so here is 64 degrees. Now I'm going to use angles of a straight line, okay, because I have this one, I have that one, now I need O1. Okay, so angles of a straight line, which means that 180 degrees must equal to O1 plus O2 plus O3. Okay, that's angles on straight line. Okay, which means O1 is then going to equal to 180 minus O3. Okay, so O3 was just calculated to be 64 degrees. Okay, and we're minusing O2, which we calculated up top here to be 64 degrees as well. Okay, and if you go and work all of that out, you should get to O1 being 52 degrees. Okay, so 64 plus 64 gives you 128, minus 180 should give you 52 degrees. Okay, now looking at 8.1.2, it says prove giving reasons that Kn bisects OKP. So Kn bisects OKP. So we want to see, now remember, bisect means cutting in half. So we need to show that the line Kn cuts the angle of K in half. Okay, so how do we go about doing this? Well, first note that KO is equal to, so KO is equal to ON. Why? Because they're both radii. Okay, so keeping that in mind, we can see that angle K2 is going to equal to N, let's label that N1. Okay, so we can state that, we can say that K2 is going to equal to angle KNO. Okay, because of angles opposite equal lines, angles op equal sides of a triangle. Okay, now that we have that, we can see that in order to calculate this angle that we need, okay, so we're calculating K2, okay, so now I'm going to use this big triangle up top here, so KNM, okay, so that's 90, this is 26 plus x, and that should be x over there. And remember, everything equals to 180 degrees. So because of angles of a triangle, I'm going to say K2 is going to equal to 180 degrees minus x, okay, that's K2 is my x value, sorry, so this should be minus 26 plus x, okay, minus 90 degrees. Should give me K2. Okay, but once again, K2 is going to equal to n over here. Okay, so once you've sorted out the algebra, you're going to get down to a value K2 equals to let's have a look here. That should give you 32 degrees. Let me just check my calculation. K2, angles of a triangle. Yes, because then what we do is you'll end up with 64 degrees, but because K2 and N are the same, we're going to divide it by 2, which means K2 is then going to give you 32 degrees. Okay, and that's because of angles of a triangle. Okay, so this should technically be a 2, and we can get rid of that over there. Okay, so now that we have that, we can see that K2 equals K1. So K2 equals K1, which equals 32 degrees. Therefore, we can say that Kn bisects, what's the one we're looking for? OKP. Okay, now let's have a look at 8.2. Okay, so 8.2 is given by this. We've got this triangle over here. They've given us that D1 is equal to B. They've given us some indicators here for F as well as D, and they've told us that D1 equals to B. Okay, and what they've asked us here in 8.2.1, it says if AF is a tangent to the circle passing through FG and D, then prove with given reason that FG is parallel to BC. Okay, so what they're technically asking us, I've drawn the circle here that cuts through F, G, and D. Okay, so technically if I just zoom in there, this is what we have. Okay, so the first thing that we can note for this is that given D1 equals to B, okay, that's what they've given us already. So if they've given you things, state it immediately. The next thing that we can do is we can see that F1 over here is equal to D1. Okay, so F1 equals D1. Why is that? Because of our tan chord theorem. Okay, but that means F1 equals to D1, which equals to B, okay, as we've just seen over here, which means technically what we have is something that looks like this. So B and F1 are the same. Okay, therefore we can say that FG, okay, which we're looking for is parallel to BC. Why? And that's because of corresponding angles. Angles. Okay, spelling's not my greatest. Anyway, 8.2.2, okay, now says if further given that AF, okay, so AF over FB, okay, is given by 2 over 5, plus they've given us the expression AC equals 2x minus 6, GC equals to x plus 9, calculate x. Okay, so I'm just going to write out everything given. AF over FB equals 2 over 5. Okay, so looking at that, we can see that this length here is 2, that's 5, so therefore we can deduce that AB equals 7. Okay, then also we have that AC equals to 2x minus 6, and we have that GC equals to x plus 9. Okay, now we need to find what x's value is. Okay, so now note that we can conclude that GC over AC, okay, is equal to FB all over AB. Why? Because of GC is parallel to this end of the triangle and FB is parallel to this end of the triangle. Even though the line lies on BA, it's still parallel. Okay, so we can state that GC over AC equals to FB all over AB. Okay, the reason for this is line parallel to one side of triangle. Okay, now keeping that in mind, we now know what AB is. Okay, we've just found that. We have GC and we have AC and FB. Okay, so now we can find what x is. So substituting everything in, we're going to have x plus 9 all over 2x minus 6 equals to FB is 5 over 7. Okay, sorting out the algebra here, we have 7x plus 9 equals to 5 2x minus 6. Okay, and if you substitute everything in and you work it all out, you should get x equals to 31 as your final answer. Okay, and that's how we go about doing this question. Okay, if you found today's video helpful, then please leave a thumbs up on the video. If you have any questions regarding this question, then please leave them in the comment section down below. I'll get back to them as soon as I can. Please go check out the channel. There are physics, chemistry, and maths paper 1 videos as well. While you're there, please consider subscribing to the channel. And remember, it's never too late to have an OIC moment.